Hi guys, our goal today is to be able to find the mean and standard deviation of a data set as well as to interpret it, okay? First, let's talk about what a mean is and what is a standard deviation. And I should have find the mean and standard deviation. There we go. Okay, better. The mean, what is the mean? The mean is just an average, okay? And how do I find an average? I'm going to take the sum of the observations. So what is the observation? That's the number in that data set, okay? So if it was your grades or people's grades in a room or people's heights, people's shoe size, things like that. I'm going to take the sum. What does sum mean again? That means I'm going to add everything up. So I'm going to add everything up, and then I'm going to divide by how many observations there are. What do I mean by that? If there's 10 people in a room, I'm going to add up their heights, right? And then I'm going to divide by 10. That's going to give me my average because there's 10 people in a room. Definition of a mean. It's an average. It's something usually we talk about in the statistic world in terms of like long term as well. Okay, what is a standard deviation? Well, the mean is a measure of center. It's like one number that you can describe the group, okay? But that one number doesn't necessarily cover everyone in the group, right? Like it's just in general, here's the average for the group. In statistics, there's always more to the story, okay? So more to the story is the measure of spread. How far out are people from that average? So are people like our heights really varying? We have really short people in the room and really tall people in the room, or do we all have really medium? So then the spread would be really big, or do we have really just all kind of the same size people in the room? Then the spread would be really small. Again, if we had 10 people in the room and we measured their heights, right? And we find that average, okay? If there's a lot of varying heights, like we have a really short person and we have a really tall person, that data is really spread out. So that's standard deviation. Standard deviation is a measure of spread. That standard deviation is going to be really big. But if I have a group of 10 people in a room and we measure their heights and they're all around the same height, okay, that standard deviation is going to be really small because a standard deviation is a measure of how spread out things are. Here's the definition. Okay, now what I have, just so you can wrap your head around the conceptual part of it, is I have 3 different dot plots here, okay? You'll notice they all go from 0 to 9, and their centers are all about the same, okay? They're very symmetric, right? What we could do is we could take all these observations. So I could take 0 plus 3 plus 3 plus 4 plus 4 plus 4 plus 4, keep going and divide by how many there are. I could do it again for B and I'd do it again for C. That would be finding the average. I'm not going to have you do that though. I'm going to just tell you what the average is. X bar, okay? X bar is the way that we can write average. X with a little bar on top of it. What do you notice? They all have the same average, but there's a much different story going on with all of these, right? Remember, there's always more to the story in statistics. So we could find the standard deviation, okay? We could find the standard deviation, which would tell us how spread out things are. Well, I'm curious if you could tell which one would have the biggest standard deviation. Hopefully you are thinking C would have the largest standard deviation. Why? Look, you guys, a standard deviation is the average difference observations, the average distance observations are from the mean. Look at this, you guys. These are so far from the mean, okay? Versus these. Look over here, you guys. I have a good chunk of ones that are closer to the mean. And here I have a lot that are close to the mean. Yeah, do I have some that are far from the mean? I do. But on average, this doesn't have any by the mean. Okay? So this is going to have the largest standard deviation, the biggest standard deviation. Looking over here, okay? Which one do you think would have a bigger standard deviation? Would it be B or A? Remember, the average distance observations are from the mean. They both have a mean at 4.5. Which one has more observations further away from the mean? Sorry, I have a virus on my computer. Hopefully you're thinking B, because look, they have observations like in the 7s and 8s and 2s and 3s. We got that 9, we got 1, 0. This one, yes, it only has 9 and 0 away from the mean, but the rest are pretty close to that average there. An average distance from the mean, this one is going to have more observations further from the mean, okay? More observations further from the mean than this one. So this would have the smallest standard deviation. This would be the next smallest, and then this would be the biggest, okay? Okay, so remember in statistics, you guys, we are more than just number crunchers. We also interpret the story behind the number. So you need to be able to interpret the mean and interpret the standard deviation. So I gave you some sentence frames for this, okay? I want you to write this down. Interpret the mean. In the long run, we can expect the average, blah, blah, blah. So what would that be? That would be whatever the story is about. The average heights of people in room, okay? The average length of football can be thrown in, okay? The average number of goals in a hockey game. To be about, and this is where you're going to put the value. And with a period there. Sorry, guys, I don't know why that's there. And here's another sentence frame for you. Okay? Standard deviation. This is one you can use. The observations differ from the mean. Okay? There's some difference from the mean, right? By an average of whatever that standard deviation value is. And I'm going to show you how to find that standard deviation value and that mean in part 2 of this video for today. Okay? So I'm going to sign off for part 1. We should conceptually know what a mean and an average is. We should have the interpretations down. If nothing else, we should have this down. In the next slide, or I'm sorry, in part 2, what I'm going to do is I'm going to show you how to calculate the mean and calculate the standard deviation. Okay? See you soon.